We are doing chapter 10 and the matching law. I'll just make a few comments in the video. It's in your book, you have a worksheet, and yes, there's a little bit of math, but honestly, if you can add, multiply, divide, subtract, it's all you need to do. And it's really, I have step-by-step instructions for you. So don't go on a math freak out because it's not that bad. So in chapter 10, right, talks about matching. What we're doing here is we're using operant conditioning to explain behavior, kind of describe how behavior happens in context. We're moving again, like we did in negative and behavioral contrast, we're moving beyond just a little stimulus response reinforcer or stimulus response punishment. We're moving beyond that little three-part contingency and seeing how does the wider context of our choices affect our behavior. So the matching law comes up when we have concurrent schedules. That means we have multiple things we could do at the same time. Now, you are going to want to do the reading and to print out this worksheet that's posted here on our daily work schedule. And when you see the beginning, let me put up just a couple of slides. Hopefully these will, show the entire slide this time. See if that happens. Okay. What we're talking about is, how do we have a certain amount of time and we can choose to do different things. And think about it, when you get home from school, you can watch TV, you could study, you could do the dishes, you can make dinner, you could, feed your dog, walk your dog, you could call your mom. There are all these competing choices. And we kind of tend to do a little bit of this, then a little bit of that. And what the matching law says is our behavior is going to be directed by the relative reinforcement. So if I have something that's 3 times as reinforcing as another behavior, I'm going to do that one behavior 3 times as much as the other behavior. That's what it says. That's the matching law right there. And so the way it's written or described might make it sound a little more complicated, but it's not. It's really very simple. So we have multiple things we could do. And all it says is the proportion of the work or the time we put toward one choice is going to match the proportion of the reinforcement. So here, here's my example with Terrence and Marco. They're both fun. They're both friends. I hang out with them. Now, let's say Marco is twice as much fun. The matching law says I will spend twice as much time with him. So for every hour I hang out with these guys, let's say I have 1 hour to hang out, and I have to do, when I said they're available at the same time, it means I have to choose. I can do one, but then I can switch, okay? They're both available to me right now. I have 1 hour to hang out. But I can only go to Terrence's dorm room or Marco's dorm room to hang out. They're both stuck in their rooms, right? If one is twice as much fun, out of that 60 minutes, how much time do I spend with each? Well, if Marco is twice as much reinforcing as Terrence, I want to break up my hour, my time, so that I have twice as much time with Marco as I do with Terrence. So out of 60 minutes, how do I break it up? Well, if I spent 20 minutes with Terrence and 40 minutes with Marco, that would be this 2-to-1 ratio that matches how reinforcing they are. So that's what I would do. I'd spend 40 minutes with Marco, 20 minutes with Terrence, twice as much with the person who's twice as much fun. Now, in real life, in our choices and our friends, we maybe can't get down to the minute, but generally we do know that things are more or less reinforcing. Or sometimes maybe if you look at a paycheck, we can know exactly how much more reinforcing one is over the other. If it's simply by payment, usually work we do has other reinforcers like, well, I enjoy the friends there at Subway and I don't care that I don't get paid that much. We have fun. So it can be a little bit murkier to figure out exactly how much time. But with pigeons in a Skinner box, it's easy to do. We can know exactly what the difference in reinforcement is as far as how much time they get to eat food. And that's where all the animal data is where we're going to get the matching stuff. But people do it too. All right, so this is one way of looking at it. The big R here means responses, so your behavior. So for a pigeon, it would be them pecking at a key in a Skinner box. For a rat, it would be the number of times they press their lever. So the big R is the number of behaviors. And then the big S with the little r, that's the amount of reinforcement. So most of this data is done on pigeons, and the behavior they're doing is pecking at a key, so we count the number of times they peck it. And the amount of reinforcement is the number of seconds they're allowed to eat. So that maybe they get 2 seconds of access to their food, or 4 seconds, or 8 seconds, or something. So anyway, we can have actual numbers that we plug into this. And then look at the little a and the little b. Little a is your choice A, little b is choice B. So there's 2 different schedules. The pigeons in this box, he has these 2 keys he can peck at. One is A, one is B. And I can manipulate how much each A and B pays out. And then I can count how many times he pecks each of these keys. Okay. And getting these numbers, what's weird is you can plug it in and you get this very reliable relationship. Okay. So as your book does the same thing in the reading that these slides are about to do. So I want you to read it there, but we'll do it as well. Let's say here there are 2 choices, a variable ratio 5 and a variable ratio 50. Now the first thing I want to ask you is which one is the better option? Like if you had to choose one of these, which is going to give you the most reinforcement? Which is going to reinforce you more quickly with the least amount of work? The VR5 is, because you only have to hit the key about 5 times. Now it might be 2, it might be 10, it's changing because of variable. But on average, about every 5 pecks, you're going to get food. The other one, you have to work much harder. So the VR5 is what we would call the better, or your book calls it the richer schedule. The VR50 is the poorer schedule. Okay. Now, given the choice between a VR5 and a VR50, where should a pigeon spend his time? Now, this is kind of a trick question, because on a ratio schedule, the faster you work, the sooner you get your reinforcement. There's really no waiting time involved because it's a ratio schedule. So given this choice, the pigeon should only really work on the VR5 and ignore the other one. It's a waste of time. He'll get the most reinforcement by 100% of his time on VR5. So now let's try a different question. What if it's a variable interval schedule? VI20, you have to wait about 20 seconds. Again, it's going to change every time to get food. The other one, you have to wait about a minute before you're going to get food. And you only have to peck the key actually once after these time periods. But since the pigeon doesn't know how long it has to wait, it's going to peck it more than it needs to. But sooner, it's going to get paid off on VI20 versus VI60. Now, with an interval schedule, you have some downtime. You have a waiting period imposed. And while I'm sitting over here waiting for my VI20 to pay me off, I know I slow down because I know there's some kind of wait involved. I might as well put some work over on the other schedule. I could essentially, the best option is to work both of these schedules. Since I have some downtime, I might as well just go ahead and peck both sides, and I'm going to get more reinforcement that way. So the matching law only works when there's a VI schedule or any kind of interval schedule, when it actually you have some wait time, when you're like, well, I'm just waiting, so I might as well do some other work for reinforcement. Okay. Now let's look at this. How many pellets, if we were going to do it by the number of reinforcers you get, let's say your reinforcer is just a 1 food pellet. In 1 minute of time, about how many pellets will I get from a VI20 schedule? This is VI20 second. Well, if I'm getting 1 pellet about every 20 seconds, in 1 minute, I'm going to get 3 pellets on that one. On a VI60, how many am I going to get? In about 60 seconds, I can earn 1 pellet. So what we have here is a 3-to-1 ratio. I don't know if that bottom thing's really helping, but for VI20, I'm going to get 3 pellets for every 1 pellet I earn on a VI60. Okay? All right. So now I want you to try this worksheet. I think I'll just kind of end the video here. Well, what I'll do is I'll have you print out your worksheet. I think you probably have to print it unless you just view it and write down stuff on a piece of paper. Pause the video to read this, because it really explains it step by step, but just pause it try it for a little bit and kind of work through it and think about it. And really, you guys have to actually try this stuff. I can lead you to water, but I can't make you drink, right? So it's not going to work unless you really give it an effort. But try the thing, pause it, and then if you're really sort of crazy confused, unpause this, and I'll fill in just a couple of numbers here so you know what we're doing. All right, so go ahead, pause. Okay, I hope you tried the worksheet. All right, so I start by showing you a completed step-by-step. And I say, okay, you try it, fill in some numbers. So just like up here, where it says VI 30 versus VI 60, what I want you to do, it says divide the bigger number by the smaller number. So I'm writing a 60 in here and a 30, that equals 2, okay? Now I take the 2 and I put it under the better schedule. The VI 30 is the better, it's paying off sooner. So I have a 2-to-1 ratio. Now to get the proportions, put the number on each side over the total. All right, what's my total? I probably have more detail than you need. What I'm saying is get my total, so 2 plus 1 equals 3. That's my total number of pellets I got. And so that means the VI 30 is paying out 2 over 3, 2/3, and the VI 60 is paying out 1 over 3. See, I'm just taking the 2 and putting it over the total, taking the 1 and putting it over the total. Okay. Now, if I want to do, instead of saying it's proportion, do percentages, I could just divide the proportions. So let's see, 2 divided by 3 equals, what's 2 divided by 3? Here, I know. Get my calculator. I can't do math when I'm talking. 2 divided by 3 equals 0.66. Okay. 0.66. Now, if I multiply 0.6, if I want to move that decimal point, 66%, 1 divided by 3, 0.33. If I want to say it as a percentage, to move the decimal point, multiply by 100, just move the decimal point, 33%. That's it, okay? Now, on the back, I have 2 more numbers. Some of these numbers get a little weird, and use a calculator if you want. If I ever give tests and stuff, I don't use anything. I do stuff you can do math in your head, like 80 divided by 20. It's 4. All right, don't go into mental lockdown over something that says, 100 minus 20 or 80 divided by 20. You can do it. Sometimes I see students like their eyes glaze over, and it's like, come on, you guys, seriously. So this is like do the step-by-step with these numbers. Oh, let's see, like, all right, what's this, 10 and 50? All right, so the first step was 50 divided by 10 equals 5. Put the 5 under the better schedule, so I have a 5-to-1 ratio, right? Now repeat the steps that I did here. You got it. This is a step-by-step thing. As you get used to it, you'll probably find you can mentally, people do their math mentally a little bit different, and you might see connections where you can jump to things and go, well, we're taking 4 steps to do this 1-step thing. And so these little boxes kind of get to that, like, there are quicker ways to think about it. So if that makes sense to you, or you find a quicker way to kind of jump through the math, because there are easier ways to maybe visualize it, great. If this stuff here is like, I don't know what you're talking about, you can ignore it and just stick with the step-by-step. But I do want you to be able to describe these things as proportions, as percentages, as real numbers. If I give you a question, I say, how many pellets, would fit that you might earn when you have a 2-to-1 ratio. Give me a number of pellets a pigeon might earn if he's matching. And you can say, he'd earn 200 pellets on this one, 100 on this. Or he'd earn 30 on this and 15 on this. Any set of numbers you create that's a 2-to-1 could be an answer to that question. All right, I'm going to cut myself off here. Let you do the reading, let you do the worksheet. There'll be some quiz questions you can practice with, okay? And we'll do a separate short video on deviations from matching. That'll be next. Good to go.